This class is real. All right, come on over here. Let's sit over here. Okay. So in this demo, all right, you're going to have some content. So there's going to be some science content, and we want to promote these some of these inquiry skills. All right, and some of the most obvious are observations, predictions. I'm going to leave the content kind of open right now in this one. So when you do a demo, you want to make sure that everybody can see it. Okay, you'd think this would be an obvious thing, but sometimes, especially in a class of 30, it could be very difficult to see some things. So you want to make sure that everybody can see it. And I think you should begin by asking the students, what do you see? Okay, so what do you see here? Water. Okay, how do you know it's water?
Clear.
It is clear. That clear is a good observation. How might we know it's water?
It's also viscous.
It is a liquid. Yeah, it is a clear liquid. But there are other clear liquids, right, Emily? Like what would be another clear liquid?
Sprite.
Sprite. That's right. I was thinking maybe alcohol would be one. Because the clear
Didn't want to
liquid.
go there. I wasn't sure if I could. I was like, bleach. I don't know.
Bleach is a clear liquid, right? Now, what would be the difference? What would make you think that this is water rather than bleach or say, alcohol?
Yeah, I've smelled
Like a
it.
container.
Have the opportunity to smell it?
You'd probably be able to smell
Yeah,
it
if
if
it
it
was
were
on
bleach.
the
Yeah. So it doesn't have an odor. So it's a clear liquid and it doesn't have an odor. Okay, and we could infer from those observations. Okay, infer from those observations that it could be water. That's another process that you do here. Okay, an inference. All right. So what do I have here? What are those? Yeah, looks like it. How do you know?
Labeled?
Innocent.
Yeah.
It's labeled.
It's not open yet.
Okay. And so how might this pop soda be similar or different from each other?
Brands.
Okay, what are the brands?
Coke and Pepsi.
Coke and Pepsi. What other differences then?
Ingredients, too much sugar.
There's diet and there's regular, and the diet would have less sugar, okay, than the others. Okay. What else can we say about these cans? You can pick them up. I want you to touch it.
Same temperature, I guess.
What's that, Charlie?
They have the same temperature, maybe.
Same temperature? Uh-huh. Yeah, they're all room temperature. Good. And this is about room temperature too, so that's another. What else?
Same size and shape.
Yeah, they are the same size and shape, same weight.
Yeah.
Mhm. What is the size of those? Okay, good. And is it solid liquid on the inside, or is there something else in there?
I'm assuming that it is soda, it's a mixture of liquid and dissolved gas.
Mhm. Well, what about that? Is it all liquid on the inside?
There's some air.
Yeah. How do you know it's air?
Because I know it's soda in the can.
So is soda carbonated?
Yeah.
Yeah. So when it's carbonated, what does it contain? CO2. So maybe it's CO2. Mhm. Well, what I want to ask you is, what will happen when we put your can of soda into this water? Okay, you all have something different. You have regular Coke, here's Diet Coke. Regular Pepsi and Diet Pepsi. Okay? Let's start with Shaoli. Okay? Shaoli. What's going to happen when we put his Diet Coke into the water? It's going to float. Okay? How many people think it's going to float?
float.
Okay, 100%. Shall we? Let's go. Let's see if it floats. You are all right. And just to make sure there's no hidden gases or anything, it's a floater for sure. All right, well, let's try the regular Coke. Mackenzie, come on around here. And before you put it in, let's take a,
I feel like
let's
it's on like the Price is Right.
predict what's going to happen. Let's predict what's going to happen.
I think it was safe. Yeah, I kind of think the same thing.
Everybody thinks it's going to sink. Okay. Good. Oh, man. Did it sink? Huh. Now, why do you think that the Coke, Diet Coke, floats and the regular Coke sinks?
I guess the main difference is the sweetener.
Yeah.
Is the obvious difference, I guess.
Okay, so let's look at the sweetener in the Pepsi and tell us what the sweetener is and how much of it there is.
There's high fructose corn syrup, added sugar.
How much sugar?
41 grams of sugar.
41 grams of sugar. That's quite a bit of sugar. How about over in the Diet Pepsi?
There is no high fructose corn syrup listed, and there is 0 grams of sugar.
Wow, big difference. Huh? So we have a can, okay? It's a pop can, and it's 12 fluid ounces. And in one, we have 41 grams of sugar. Okay, in the regular, in the diet, we have 0 sugar. Okay, where is that sugar located in the can? Here it is. It's dissolved. It's dissolved in what? Water. Okay, so the sugar is dissolved in water. Okay. And is there any other sweetener in there? I mean, is there another ingredient that causes it to taste sweet?
Aspartame.
Aspartame.
Citric acid.
Citric acid. These are artificial sweeteners,
Yeah, I just have citric acid.
and they're very, it's very, very potent, so there's not much in there. All right. So what's going to happen with these two? Emily, you're up first. Regular Pepsi, what's going to happen?
Okay.
All right, let's go. Absolutely right. And Randy? Float.
Yes.
Yeah. See if it's true. Good. Excellent. All right. So this demonstrates a property that we want to focus on today. Okay, in this particular lesson. And I want to emphasize that this has to do with density. Okay. And how do we find density?
Mass over volume.
Mass over volume. Okay, equals mass over volume. Okay. In this particular demonstration, Randy, what was the mass that we were considering in relation to the pot?
The mass of the liquid,
Mass of the liquid.
assuming the mass of the can is equal to this one.
Liquid, okay, in the can. And what was the variable that we discussed between the diet and the regular?
For
Just sugar. Okay. So the sugar is dissolved in the liquid, okay, and that's in the regular. Right. And the volume, what was the volume of all the cans?
12 fluid ounces.
12 fluid ounces. Okay. And the mass on the diet side was, the variable was the aspartame. I think that's how you spell it. Okay. Well, this is what we want to talk about. Okay, mass over the volume. Right? And that's what determines the density. And if we consider the density of water to be 1, approximately 1 gram per cubic centimeter or milliliter, then the value of the density for the diet products would be more or less than 1. Less than 1. Okay, so this is less than 1. Okay, this would be more than 1. That's gram per cc. Gram per cc. Okay. And if it's less than, close, it's more than 6. And that's our estimate on density. Oh, I forgot to ask you. If you go to your grandparents' picnic next summer, where are you going to reach for your pop in the cooler? In the bottom, because you want the sugar. Okay. So you can remember that next time you're out on the river or the cooler. The diet's all full. That's a demo. What do you think? You like it? Yeah, that's a good demo. You can stay, let's stay there for a second. I've got I want to turn this off. So I have another one of these process diagrams for this activity. What do I need? The materials and preparations. Ask the students to make observations. Volunteers. Key ideas. Introduction. Exploration. Application. This is like a lesson plan. Okay. It's a lesson plan for this thing. Any thoughts? Any comments? This is the way you learned it with Dr. Graves, shall we?
Oh yeah. Something was funny. Forgot the name of it. This good event.
Discrepant events, yeah. Discrepant events are another way to do this. This is where you do something that the students expect one thing and they get another. It's a discrepant event. And sometimes with misconceptions, discrepant events are a good way to address misconceptions. Okay, so that's another one, discrepant events. That's another way to think about it. Okay, this is what you're going to have to do next week. You're going to have to do a demo. Well, what are the key? What are the key ideas? Okay, you can see it. Have everything ready. Okay, make observations, ask questions, use the board if you need it. Usually, for abstract things like this stuff here, you need to write it down so the kids can see it. What do you think?
I mean, I guess what comes to mind is that you've got, what looks like a lot of words and stuff to get through, but I mean, the demo took 5 minutes. So,
Maybe a little longer. Yeah. If you know what happens for a lot of people is that once they start talking, they can't stop. And so I've seen, your demo could go 15 minutes if you want. 15, I think, would be a lot. Another key thing about demos is, what if I just use Coke and we didn't do the Pepsi? Kind of would have limited it. Okay. So even though it kind of seems crazy, it's a good idea to do the demo twice. Okay, do the demo at the beginning, where you're making all your explanations and all that other stuff. Go into the explanation in the middle, and then at the end do the demo again, and ask the students to tell you what's going on. So we've got other, we could have done it again with these. We've done it with these. There's another thing about demos that sometimes happens. Okay, so what do I have? Coke, right? Regular Coke, sealed. It's empty, practically empty. The pop just leaked out of it. It's so old. Just leaked out of it without opening it. I don't like tricks. That's a trick. Okay. So this would be the trick. It would be like, it's not a discrepant event, it's just really a trick. That's what it is.
Could ask us to then why this one low.
Yeah. You could, and we could, you probably want to look at hold it eventually instead of trying to trick it. There are other tricks I know, some are more crafty than others. But I think we should just start out with just straight demos without trying to do tricks, okay? Alright, you want to do another one? Some more fun?
Yeah.
Let's go in.
Yeah.